Claire, are you able to see my stream? Claire, are you able to see my stream? Claire, are you able to see my stream?
Oh.
It's gonna repeat forever now.
Your link?
Yeah.
See.
Well, let me get a better cat cam.
You big cat.
It's a good. Is that a good angle for the cats?
Archer boy. Look at him.
Yeah, that's a good cat cam right there.
Cute. Can you get it a little further on his body
Let's see.
without scaring him away? Oh, you had it.
It's like hard to doesn't quite want to go.
And then
About that. That's not too bad, huh? Are you able
yeah, there you go. Cat cam.
cat cam?
Cute.
Okay. So we can kind of let's post this. Okay, I guess I gotta pull. Make sure everything works. Cool. All right. We're in a good spot to do some stuff. Do some fun stuff. I think trying to get rid of these vectors is probably the next thing. These tree walkers. Because I don't necessarily, I'm not in love with the idea of having vectors in these things. I don't think these are dynamically allocated or passed around or anything like that. There's just a lot of them. So let's tweak our build script and get it to where we just want to build. Right. It's just kind of a thing I do all the time to help iteration time. So now I can just be like, I don't build any of the assets or anything, it just compiles the editor. Cool. So start with front buff. So here, oh, it's gonna be the easiest way to do this. I think we break one at a time, and then we address all of the things. So let's start here. Right. Actually, maybe we just do them all. Well, let's see if this thing's actually moved. I don't want this thing to be passed around. So if we delete this, will that actually break stuff? Okay, no, so we don't have to worry about that, which is nice. Just have to worry about the destructor for this, which we're about to get rid of because this is going to be gone. Okay. So, can do this all the way across the board. So this is the arena that we're going to start allocating the stack into instead of having it be a vector. And we'll make a data structure for this later, but let's resolve all of the compiler errors around that thing first. Let's save this. There's a bunch of stuff here. Right, we're going to need to address this, so let's give this an arena. Okay, actually, let's make this a Scratch arena, because I don't think... Eventually, this API is going to get an arena for this guy. But not right now. No complex. Since we don't need this thing beyond here, we can just end the Scratch down here. Cool. And then we can do... Cool. Gotta do the same thing here. Complex. Let's actually copy that line because I'm going to need it in a couple of places. I have a runtime mechanism to catch if I forget to do this, because I don't want to do it manually. I don't really rely on destructors in as many places as I have been. Go to the next one. Same deal. Scratch. Eventually I want to get to the point where I'm editing Fred using Fred, but for now, I'm just going to use VS Code. Let's go to the next one. Okay, so here is the actual parameter. I'm not going to do anything with it yet. But we have it. Because eventually we want to get to the point where we're kind of pushing this stuff onto the stack, and we have like a saved arena in here that we can just keep like pushing stuff into. Now I'm kind of torn on whether or not I want to continually pass the arena into this thing and have it allocate every time. The thing is, like, you never know when it's going to actually need the arena is the thing. Like, only this data structure really knows when it's going to start pushing stuff onto the stack. Like here, right, we just arbitrarily push back or pop back or stuff like that. So I think we might actually just want to... I think we might actually just want to save the arena inside this data structures, because they're really short-lived. They're not meant to live past like a single call to an API or a walk of a tree. So let's fix up all the other constructors here, though. Right. So it's here, here, and those are the only two remaining. And then finally we have some stuff in here where we need a scratch arena. Conflict. We're gonna need the arena past this, right? So we only walk the buffer so we can actually kill it here. Cool. So now we fix the myriad of places that are broken after this. So why are these broken now? Because why is this broken? Expected a declaration. I suspect. I actually expect that that's kind of like a bug in IntelliSense. If I reload this. What if you pass a pre-allocated stack into the tree walker, which is the size and height of the tree? You definitely can do that, right? Because this when you pass the root of the tree here, actually, because all of these really take, so the snapshots and the tree know their depth. So in theory, you could kind of do that. But the way I've been using the arenas is that they should have generally enough space to kind of just reserve this small little data structure entry here. So I think the actual benefit you would gain by doing that is fairly minimal. I can experiment with it though. That doesn't seem like a bad idea. But the thing is, like, you have to push and pop because you may go down different branches which have all the same depth. So you're gonna end up pushing and popping like down to level 2 and then back up to 1 and then down to 2 and then 1, right? So you need to be able to continually add those nodes. And I think just having this be a list of nodes is probably just a simpler solution. And because these are so small, like this thing is just a pointer and this thing is an int. So this is pretty cheap to just arbitrarily allocate. I'll kind of experiment with that. That might be an interesting idea to play with, though. I don't know why these are complaining. Oh, okay. That's because this needs... Right. C++. This iteration model kind of can't work anymore for like a for each loop. I kind of almost want to get rid of this. Like the fact that this just returns a tree walker that actually relies on internal allocation, like this actually is hiding a ton of allocations today. I kind of don't, I'm not in love with that. I'm not in love with this thing. This is only necessary because of these two as well. So I'm not in love with any of this stuff. I kind of wonder how far I can get if I just don't use this. But just for the sake of making things compile, let's see what happens. Let's just get this to compile. I want this to just explode at runtime. We gotta include CAssert. So let's just CAssert that for now. Okay. I don't actually think I use this in any editor routine. I'm pretty sure I don't. Yeah, these are all the places that are going to be that will need to be patched. Maybe not this because this takes a pointer, but we'll see how bad it is. So yeah, there's a bunch of them. There is a bunch of them. Let's start an edit, I guess. So this walker never escapes the function. We can just very easily push a new arena here. So we don't have any early returns. I can just kill it here. I'm going to actually save this to buffer because we're going to need it. Yeah, you can see all this red that's happening. I eventually want to get Fred to the point where you can do this. So once the project system is integrated, I want to have like a little mini map, kind of like VS Code does, because it's kind of helpful to see where like diffs are or like errors happen. Errors should be pretty easy. It's just a matter of invoking the build and then parsing the compiler output and seeing what lines contain errors. In this particular case, right, like you could have one column for errors and one column for like diffs and stuff like that. I think that would be pretty useful. But anyway, that's a future thing. I think this is good. This scratch buff is gonna have to completely go away. I hate this thing. It's just a giant string that continuously grows and it pulls out arbitrary pieces of text editor line ranges and stuff like that for other components, but it really needs to go away, and we need to be explicit about the allocations that are happening on that. So that's probably a future project. But let's keep focused on our tree walkers. Right, so we have another walker here. So the code point walker does not actually have this stack problem. It just holds a pointer to the tree, and then it computes UTF-8, or it computes code points based on whatever the current offset is in the walker. So it doesn't hold any information beyond what the walker actually has. So we don't need a special thing just for that. So for this, I need to convert this into a result. So code points. Let's start it with UTF-8 invalid. Why is this complaining? Code point result. Valid code point. Oh, I had it. Because of course I think it was just a misnomer. I should probably fix that, but whatever. So if it's exhausted, or actually let's invert this. So if it's not exhausted, we want to do this. If it is exhausted, then we want to well, actually no, that's still wrong. Let's keep it how it was. So if it is exhausted, we want to assign result to well, now I keep second guessing myself. Equals this thing. Otherwise, we're just going to return result because it's already set to invalid. Right? It's not exhausted. I need to invert this, of course. So tree walker needs our scratch. And now I can deallocate the arena. Cool. On to the next one. All right, what are we doing here? So we allocate a tiny walker to find the matching token, and then we're done. So these This reverse code walker, we're going to come back to this because this actually has the exact same problem, but we're addressing this one for now. So what we can do actually is allocate a single scratch arena for both of these. No conflicts. I don't think there's any conflicts in this function, right? We're just computing some enclosing information. So I'm here. Got this. So now we can use. Cool. And now it has its own allocation structure. Next. This is kind of tricky. I kind of hate these. I'm like really starting to hate these functions that just return early. I think we want to convert these into single return functions. So like this should end up just being a break. And we set distance equal to this thing. So I think what we want instead of this is dist equals and then break, right? Now we can do our arena allocation. Cool. And now we can next. I think that gives us the same semantic. And we'll test all these things. Actually, I should be making a note of this stuff. So I want to make a note of the functions that are a little bit weird, so I make sure to test them whenever we get this thing compiling. Okay, there's no early returns here, which is nice. So let's get our scratch arena. So cool, that was easy. Next one. A lot of these are going to be super simple, which is nice. Okay, so this is another early return. So I think we want to start result off with equals nil result, right? Because we're setting all the fields here, so we can just actually break and just return result. If it hits this case a whole bunch of times, that should be fine. That will give us the same semantic. Yeah. Yeah, I think that makes sense. Oh boy, this is kind of weird though, because this actually fires on every single thread. But I think it's fine. So if we have a scratch arena for this guy, right? This is all the arenas in this system are thread local. Thank you to Ryan for suggesting how that should work. So this should just work. Cool. Yeah, Walker has all this stuff. There's no early returns sneaking up out of nowhere. Should be good. Should be good. Okay. Compute line guides. Does this have an early return? Okay, we don't have an early return, which is nice. Yeah, this is the function that's single-handedly responsible for computing all of the line guides that you see in Fred. When you see stuff like these lines here, that's computed on a background thread. Because when you open up a huge file, like, for example, if you're on a slow machine, you really don't want to block. You don't want to block this. So we allocate that on the background thread, or like we compute all this stuff in the background. So extra buffer information like the line guides and several other pieces like, oh, where are these enclosures at, right? Like when I can jump between these two enclosures, like the closing curly, that's all computed in the background thread. So we don't block on anything there. Anyway, little piece of Fred tech there. Okay, so scratch. Now the question is, I don't want any early returns sneaking up out of nowhere, so we should be good. Okay, so that's nice. And again, this is all computed on the background thread, and this is thread local, so we should be fine in terms of safety. All right, what is this? Do I early return here? No, we're good. Okay, so I can allocate my scratch. And deallocate it. Cool. Next. Extend by chunk. This is kind of a weird function. So this is the thing that's responsible for like word movement. And it's kind of a tricky function to get right? Like, because you want, like intuitively, you want to be able to skip words. But what counts as a word is a little bit up for debate, right? Like here, I'm skipping quote unquote a word, but really it's like non-identifier characters, right? You want to skip all of them and get to the next identifier. You want to skip over that and then skip over this. But you notice how VS Code, whenever it skips over things like this, if the first thing is a non-identifier character, and then the next thing happens to be an identifier, it actually lets you skip the whole thing, which is kind of useful in a lot of cases. And that's the behavior that I mimic in this function. So let's make sure there's no early returns. Okay, we're good. So we can allocate our scratch. Cool. And now we can deallocate it. Go to the next one. There's only a couple more in here. There's probably like 6 more in here, something like that. I think I'm really fearing the render text pass, right? Build text core. This is the function I'm kind of scared about because this is the thing that's responsible for rendering all the text in Fred, and we got to get this right. So let's get it right. Make sure that I have an arena that's going to work. Do I have any early returns? No, we should be okay. We should be good. And actually, I kind of want a scratch arena for this whole thing. And the reason is because eventually this is going to be arena allocated. So being able to have this arena allocated would be super nice. Right, like line text, that's just getting the entire line of text. Okay, well, let's start. Prop scope, I want this to be part of the scope profiling. And actually, we can deallocate it down here since there's no early returns. Okay. Let me just double check that. This is the kind of bad thing. Like, you start with a style of code where you think early returns are super nice, Oh, thank you, Yui, for following. Appreciate you. But you get into this mode where you think early returns are super useful, and a lot of times they are, especially in short functions. But when you jam them into really big functions, bad things happen when you go to refactor code and you want to remove some complexities like destructors, which is kind of what I'm doing. So you gotta have to be really careful about that kind of stuff. I still believe in early returns in short functions because those are super easy to reason about. Larger functions, not so much. Yeah. So this one has a whole bunch of early returns, but how much of this walker do we end up using? So we only use the walker to allocate this scratch buffer. And what we're doing in this function, apply selection to cursor. So we end up computing, let me remind myself what this does again. Oh, okay. I think I get what this is doing. This is taking a cursor location and it has a selection. And what we want to do is we want to produce the string content of that selection. And that's what this is doing. And that's why we need the walker here in this case, because the walker is responsible for walking that set of characters at the starting character and then producing the string, which is this thing. Okay, I'm on board. Which is why we don't need it past this thing. And so do we use this? I kind of want to make this its own scope. Or, got that backwards. So I kind of want to make this its own scope because I don't want Scratch to really, or I don't want Walker to escape here. So I might just do like a little this thing, right? This actually needs to be out of here because result is computed later. Length. Okay, length is also going to be up here. Okay, we're good after this. Right, and now I can kind of control this scope. We've wrangled it. Next. So this thing, we generate some clipboard stuff. Okay, this entire function needs its own arena, because eventually, like, this buffer is just going to be arena allocated, so having it be here is fine. Make sure there's no early returns again. Nope, we're good. Okay. And then this one. Cool. Whoa. Oh, okay, we're not done. I was like, wait a second, that can't be the last one. Okay, this... Why does this one have an early return, but the other does not? So if we do not have a selection, we want to get out of here, which makes sense. But I think what I might do is I might invert this and then just kind of indent this code to keep it one return we can use for everything. Because this is the only path that actually needs to return. Right. And this way, as we create multiple walkers in this loop, we can just keep reusing the same arena. And we only need to allocate one arena here. Yeah, I think I might do that. So if we have a valid selection, we want to do all this stuff. I typically hate doing this, but I think in this case it sort of makes sense. And it's not too bad as far as indentation goes. Let's get our scratch. Cool. Let's keep going. So we have these two that we need to change. Right. Once again, I think multi-cursors are amazing. That's why I support them as a first-class editing citizen in Fred. I think they're just so awesome. This is gonna absolutely need a change. Hate this. These early returns. It's kind of a shame because they're actually like kind of useful early returns, but let's make sure there's none down here. There's no returns. Okay, good. All right, we're good. We're good. We're good. We're good. This whole function is super messy. And the whole purpose of this function is that whenever you select text in Fred, what happens is that, and you copy it to the clipboard, we actually copy metadata, which preserves like the formatting and the syntax highlighting as HTML. This is a clipboard format supported by Windows. So when you have that HTML text and you go to paste it in something like Outlook or Gmail's message composer, it will spit out as formatted text, and it's like syntax highlighted, and it looks really cool. I can actually give you an example of what that looks like. So if we have this, and I go to, let's pop this out. Can I pop this out? Okay, yeah, there's pop out. Oh, come on. I just don't want to show my like full email on stream. Can I pop this out into a window, please? Well, I think there's, I don't know. Yes, yes, exactly, Ratchet. You're exactly right. And the way I do that actually is this the arena parameter. Let me actually pull it out again. This arena parameter is actually an array. So whenever you pass in or whenever you request a scratch buffer and you you also have an input arena that might match something that the scratch could overlap with, like you have a caller, then you actually need to make sure that, again, there's no conflicts. And you already know this, but I'm saying this kind of just for stream, I guess. Yeah, if we actually look at the implementation of this function, right, we go through and we make sure that we don't have any conflicts. And because if you do have a conflict, you're going to end up like pushing stuff on and overriding a result that the caller needs. So when you go to do the scratch end, you end up just deleting the data that the caller needed. So anyway, this prevents that from happening. And I actually have a tracker system set up to where if you have an unbalanced scratch and you forget to call like scratch end, this tracker system will pick that up and be like, hey, you know, there's something totally wrong here. You should probably figure out what the heck is going on, right? And that fires on the thread pool, and it fires on the main thread because you need to be able to catch this on a per thread basis. So anyway, yeah, that's why we need to do that. And you're absolutely right. We need to catch that for the buffers. But the thing is, with all of these other allocation functions, The actual text buffer itself is never allocated as a Scratch arena. It's handled by this buffer manager API. So this entire file is dedicated to the management of buffers. And this will 100% ensure that we never end up with a Scratch buffer assigned to a text buffer. So I kind of know that, like, at least for the text buffers, this will never come into play. And the same thing for the editor data itself, too. So, like, the data that's inside the actual editor, this thing will never end up pointing at a Scratch buffer. The only time Scratch buffers get involved is when they're an explicit parameter to a function. So hopefully, at least as of now, cross my fingers, right? At least as of now, there hasn't been a case where I've run into an overlapping Scratch buffer, because I'm really trying to be careful about how I use these things, and they're always like kind of in a very contained way, only ever on the stack. So let's do yeah, and if you're curious about like what this thing looks like, right? This conflicts, it's just an array. Well, really, it's just a pointers, and then a count, and then we just iterate that thing. So we have our Scratch. Let's give it to our parse tree builder. Cool. There's no other hidden returns as far as I can see. Yeah, we're good. We're good. Let's go next. Check spelling. Yeah, I need to rethink this. Thank you, past Cameron, for letting me know that I need to rethink this. Yeah, misspelling, or the spell checker in general probably just needs to be reworked a little bit. The actual algorithm is fine. I think the way that we end up caching them is not so fine. And I've run into a couple of weird bugs around that. But anyway, this should be pretty easy. I don't think there's any early returns in here. Yeah, we're good. So let's start with our Scratch buffer. And let's do arena here. And let's end it here. Cool. Next. Next. Okay, this is annoying. Because this is in... We're going to gather suggestions. We're gathering up suggestions for the autocomplete. So when you're typing in words here like edit or this stuff is computed on a background thread. So when you type in a word like that, manager, and you autocomplete it, the actual suggestions themselves come from background thread computation that's loaded per buffer right now. So like you won't get suggestions from ed.cpp inside of edmanager.cpp. Eventually, the project system is going to unify all of that stuff. So it's going to be more driven off of the semantics of the project. And I'll be able to get suggestions for like header files that are included or something like that. Similar to how like 4Coder does it. But anyway, and 4Coder is really not, it's in a good position to do this because it actually parses, like quote unquote parses C++ or C, right? It's got that nice little luxury. But I want to try and support C++ as best I can. So I'm in a uniquely horrible position to deal with the tree sitter output. But honestly, that's nothing against tree sitter. I think tree sitter is great. It's just C++ is weird. Okay. So cool. Next. we done? I think we're done, at least with editor. So let's try. I saw a couple of other ones that were broken. Right, there's util. Fredbuff is still broken. Oh, right. I never actually fixed these things. Oops. I also hate that about VS Code, how it like deletes identifiers in front of your suggestions. I don't agree with that change. I think it needs to go away, but whatever. That's just me. So yeah, I just never actually used it, which is awesome. So in regex, yes, regex is coming. I am working on it actively. I'm just building up the data model. I have it parsing, but now I just got to make sure that we get all of the matchers working how they're expected to be working. Yeah. Regex, I think to me, I know a lot of supporting regex is kind of like a weirdly controversial thing. I don't know. I think it's still useful because the fact that you can sort of batch up searches into one regex is super helpful for me. So I think it's a worthwhile investment for me to support it because I will use it. Anyway, that's not what we're in here to do. We're in here to fix this. So we got our Scratch Arena. All right, this is the title of this stream is really apt because I've been using STL data structures to kind of bootstrap just about everything in Fred, and it's worked out pretty well. But I'm kind of sick of the fact that I don't really have fine-grained control over the allocations. Like the memory management in general is just it was managed, but it was managed in a way that I'm kind of uncomfortable with because I don't have direct control over how memory is released, and I didn't have direct control over how stuff like ref counting works, or even if it does work cross-platform and stuff like that. But by building it all myself, I will have more direct control over how this works, and essentially like the synchronization points. So the thing I solved, I wish I had streamed this actually when I was doing this for Fredbuff, because Fredbuff I recently took from being STL allocated with stuff like smart pointers and all this nonsense, to now it's completely arena based, and I'm able to do things like sharing node allocations in the tree structure a lot more aggressively. So like the tree Fredbuff red black tree, I modified the heck out of this thing to give us like this node structure where I can have this like node block concept, and this block contains it contains references to the tree block, which has references to all the allocated nodes. So whenever a node becomes ref counted dead, it will be placed in a free list in an atomic way, and I can reuse that free list as much as humanly possible for this specific Fred buff. And it actually turns out to be a really good win in this case, because before it was all just shared pointers, so I didn't exactly know if the underlying allocation mechanism was sharing the data as much as I had hoped, or as much as I was hoping for. And it did end up being this weird combination of like, oh, I don't actually know if my allocations are working out the way I think they are intuitively. But now they do, because I am controlling it very explicitly. Yeah, I'm kind of just like... I appreciate the call out, but yeah. Let's see. Yeah, yeah. So I think that applying this same concept here, where we have like the tree block. Let me show you the definition of this because I think this might be relevant. And I could probably share some of the implementation with you, Ratchet, if you're curious. So the tree block, like I said, it has this free list of nodes where we decrement the reference atomically, and we know that it's like a dead node. So it goes on here. And then the allocation arena is tied to this tree block thing, which is responsible for all of the allocations inside the nodes themselves. And then of course we have this node pop mutex. This is the only synchronization point you actually need, and it's only necessary for when you deallocate a node or when you allocate a node off of the free list. Otherwise, this thing is not useful. Or otherwise, this thing is not neat. So, like, if you just keep adding nodes, you won't actually run into this lock. And it actually turns out to be a really nice win. Like this editor is still, it's in debug mode, and it's like super fast, right? Like I can actually add like tons of multi-cursors, right? Actually, let me do it in a way that you can see. So I add a bunch of multi-cursors, right? And we're adding tons and tons and tons and tons and tons of nodes, but it's like instantaneous because, you know, the allocations are very straightforward and they're reusing the intermediate results as much as possible. That's a whole bunch of stuff. So it's kind of cool. You could do a push and pop atomically. Yeah, I thought about doing this. I guess I probably could do that if I did this like an atomic assign to this list. I need to think about that a little bit more, but I'm pretty sure you can get rid of this mutex. I just have it there as like, hey, you know, this is just the one synchronization point that exists. And actually, I don't even lock it, or I kind of lock it not as aggressively. So if I look at free list, right, I first check. Oh, so in the decrement, you absolutely have to have the lock. But in the case where you actually need to allocate, you can first check to see if there's something there. It doesn't actually matter what this result is. Like even if it's being intermittently written to, if you have any amount of data here, that's fine. But at that point, like when you know there's some kind of result there, that's when you actually need a lock and start assigning and figure it out, right? But otherwise, the mutex is not used in the general allocation case. Let me. Where's my panel for moderation? Trying to find Twitch. I feel like Twitch keeps like changing where these things are. Mod actions. This is the one I want. There we go. Let's put you down there. Twitch, what have you done? I feel like I never know how to use this interface anymore. There we go. Of course, the mod button is like deleted. I'm just gonna delete that because we don't need this. Yeah, yeah. It like there's a the little gear icon has like the mod actions turned off by default, and I don't know why that's the default. But anyway, yeah, I eventually got there. Okay. Where were we? We were in this guy. Okay, we just finished regex, and we need to get to the next thing. So util, and there's there's one here. Right, so save file. Save file is actually kind of, I try to operate in 4K chunks. Actually, this should just be 4K. In 4K chunks. So it's kind of like nice for Con.io and all that junk. Actually, Con.io doesn't really get in the way since I'm doing the OS write level stuff, but just in case this for whatever reason you want a detour write file, you can do that and you'll only get like 4K buffers. And generally the Windows API likes to work in 4K buffers. I'm not so sure about Linux. I'm not so sure about Mac OS, but Windows really likes 4K buffer sizes. So, are there any early returns? There are not, so we can do this, right? And we can do this. I'm gonna put this here because the way the open file happened first. So I kind of like to preserve some kind of destructor order. Cool. Are we compiling yet? Okay. Where is this stuff happening at? Oh my gosh, they're in template instantiations. Okay. Ah, that's why I didn't see it. Wonderful. Template instantiations. Because the compiler doesn't like to do them early. So let's get our... So we got... No async IO. There is... So the async IO part, this save file actually happens on a background thread. So whenever you click save in Fred, it fires off an event to the save, or it fires off a save request. And that's why we actually end up getting a reference snapshot here instead of like a full tree or a reference to an editor. So this save file happens completely in the background. And the editor knows, or like the system knows when a save is happening. So if you hit save like multiple times, like you make a bunch of edits and you hit save multiple times, it won't try to like overwrite the save that's already in progress, because you'll obviously hit like write errors all the time, because you can't have like two write handles open to the same file, for example. So it knows when a save is happening, so it'll just queue up like another one, essentially. That's how the task system works in Fred as well. So like the task system is all based on like you can queue up a task, and then you can queue up a cancellation of that task, or you can queue up like a redo of the same task, which reuses the same task allocation as well. So this does happen in the background. But even still, maybe it'd be a good idea. It might be a good idea to change this to an overlapped IO. Or actually, internally, it is an overlapped IO operation. So it won't like lock the system. Only this one like thread if for whatever reason bad stuff is happening. Let's get rid of that new line. I don't need it. Okay. More template instantiations. Oh, this is an ed still. Search for needle. Okay, yeah, this is the one that happens on the background thread. I'm pretty sure. Let me check. Yeah, compute search results. So this is the one. Okay, this happens on a background thread, but the main thread waits for it. And the reason is so you can see search results instantly. So like when you do like a search like this, those all compute on a background thread, and you can kind of see this like noisy search, if you enable this, you can see like all the threads and like what they're doing. Essentially, there's like the threads all search a chunk independently of each other, and then they join at some point to the main thread, which is synchronizing all the search results. So like it's a main thread quote unquote operation, but it's so fast that like I've not really noticed any observable difference. And actually this is kind of how VS Code does it as well. So they do this like incremental search on the main thread, but they just spawn a whole bunch of threads in the background to search out chunks. And that actually works pretty well, especially when you consider the search algorithm itself is extremely fast. So when you're operating on an individual chunk level, that search is like almost instantaneous. And this is like a 10,000 line file, right? Like it's huge. But you can find files that are bigger than this, like rad debugger, debug build. So this one, I actually just pre-processed rad debugger just to kind of like test on it. So like this thing is 618,000 lines, but like, I mean, the search is pretty dang fast. Like 64 milliseconds might be noticeable in some cases, but this is this is a debug build, and two, like as you're searching, like it still feels like really good to type. So I don't really notice it. Anyway, there's that. Right, we're going back to our error, which is this guy. So we want to make sure that there are no early returns. Okay, good. Begin. No clicks. Cool. And then we're going to kill it. Cool. All right. Where was this other error? Different line. Here it is. I kind of like the actual thing happening there. So what is this one doing? Oh yeah, this is the enclosure. So this is the thing that I was talking about where we compute like the closing and opening curlies of functions and stuff like that eagerly. So like you can do this like jumping around thing. There's no early returns here, so we can actually just do, we can do our scratch. Man, at this point I should just do a macro for this thing. And then cool. Yeah, and then we just make sure that it's sorted at the end. Because these enclosures, if they're not sorted, then you'll get really bad behavior when you're jumping between these, like the things that don't match, like the brackets and the parentheses and stuff that don't match. Okay. What's the next one? 1376. I think we did this. Yeah, we did this one already. Oh, tree sitter. Okay, here's tree walker. Okay. So this all happens on a stack. Yeah, this all happens on the stack, so I'm pretty safe to just kind of like allocate a scratch arena here. And then But are there early returns? I don't know. This is all in a lambda, so it doesn't matter. We should be good. How close are we? Lots of breakage. In ed? What? Oh! Like 1736, I think is what it were. Close enough. What? Oh, 1782. Right. That's just so silly. I should not have done that. Okay. I probably made that mistake in all of these places. 1782, 1376. No? What was it complaining about in 1376? I don't know. 1376. Wait. Oh, that's in Fred Buff. I should learn how to read. Okay, so we have this thing. We need to convert into a return. Let's assume no, so because that's what it is here. So no, break. And this isn't a nested loop, so we can just do this. This is one of these functions I'm definitely going to have to check. Trim CRLF. Okay. Yeah, we have a single return, so now I can do this. I think we should be good there now. Bridge. Yeah, I made the mistake. Scratch end. There we go. There's a whole bunch of errors down here. Oh, probably they're all related to the same thing, so if I build it. One more, Fred Buff. Initializing 1378. What is going on there? Oh, right. That would help. Okay, now that we got it compiling, I want to see how possible it is, because we're not actually using the arena yet. We want to actually use it eventually, but I want to see how possible it is to get rid of this nonsense. How much are we relying on this? I hope none. Okay. There's only a couple, which is nice. Actually, not very much at all. There's one place. It's down here. So we get it for the internal buffer. Now we can just convert this into like a get everything, right? this thing. Okay. Yeah, and this for each loop is going to need to be replaced. By the way, tip from a compiler developer, if you're wanting to comment code out quickly, just use ifdef. ifdef is so much faster than like actually commenting out the code, and it lets most editors preserve like things like syntax highlighting, and like I could still jump between these. But if it were a comment, like sometimes like some editors won't let you do that. Like VS Code doesn't really do that. It'll just jump to the enclosing one. So yeah, use ifdef blocks. They're much better, much faster way of commenting code out. So let's start a tree walker here. So and then we want to get the buffer. And we want to start at the beginning. So like the default is like start at the beginning of this thing. And we want to go to while it's not exhausted. Cool. And that should do what we want. Because that's actually like what these things were doing. So tree walker, the plus just advances the next. This is actually kind of a no-op. This is actually kind of just terrible design, actually. And Ratchet Freak pointed this out, and I totally agree with them that this is just terrible, right? The operator star should not be doing the next thing. But actually, weirdly, that's kind of like what reverse iterators do in a weird way. They kind of just like access the next thing. But the fact that you can't call this multiple times is really obnoxious. Yeah, I do not like this API, and I'll probably delete it. It was only there to help make like this thing possible, but this isn't really that much more code to write. So, I'm just not, I don't miss it. I'm sorry for each loop, I don't miss you that much. But let's make sure that compiles now. Okay, that's everything. So let's delete that API. Let's delete this code. Let's delete that API. This whole stuff, boom, gone. And we no longer need CSR because we were only using it there for that. Do I even need this? I don't think I even need this. Right, or that's in the reverse. I want this stuff. I should be able to get rid of that. Oh. No, I can't. Why? Oh, util. Oh, gross. This, yeah, utils depending on it. Okay. Oh, that is obnoxious. That is absolutely obnoxious. So instead of doing this, I just do walker next. And since this was a no-op, this is just like nothing, right? Yeah. Absolutely silly. Just an absolutely silly API. I'm glad it's gone, actually. Okay. Now we actually we do the fun part of making this work. I think for now, what we might end up doing is, this obviously can't be a vector anymore. It's got to be like a linked list. I think I'm just going to make it a linked list of nodes that don't have a free list, because I think free lists would kind of just be overkill for this. All we really need is like a single linked list that we could push and pop these stack entries to. So And since these allocations are like pretty small, well, we could just have two singularly linked lists. Like one is the stack and one is the free list. Right. Yeah, the depth is known for sure. And so I think it's really like we could just allocate a little array that has the stack or like the actual like stack entries there. Do I care? Do I care to do that optimization? It's like that's the question I'm asking myself. I think for now I just want to get it working. I think for now I get it working. So let's have stack and let's have free list. Because already annoyingly enough, I'm gonna have to like destroy these things as they're allocated because also does this share the same structure? This is the same exact structure. I'm gonna yeah, it's annoying. I'll refactor that a little bit later. Um, yeah, I want to refactor this and pull it out of these data structures so we don't have like these nested types. I think these nested types are completely unnecessary. So we're gonna have the stack and free list. They're just one pointer, and then we just walk the list. It should be pretty small in general. So I'm not like super offended by the pointer space here. Yeah, the only thing too about computing the depth is that I would need to think about what an API on the tree looks like to do that. Um, because I also need it on not just the trees, but like the reference snapshots and all that stuff. Like they would all need to carry like the max depth, probably as part of the buffer meta. But that also involves like a longer walk of the tree and like kind of like in a because you could go down a branch. Let me show you the issue. To compute this information, we don't actually have to walk the entire tree. We only walk down one side of the tree to get this, and then we only walk one side of the tree to get that. So, like, that one walk is all we need. However, those branches might not be the max depth of the tree. Like you might not hit the max depth of the tree going down those branches. So to compute that last element to figure out what the depth is, you you would need another obviously you need another element here. However, the walk you would do to compute this stuff would be a little bit more inefficient. Because red black tree, unless I preserve it in the red black tree itself, RB tree. So if I preserved that information in the tree itself, like maybe I don't know, you can't preserve it in the node data. You would have to you'd have to know that here somewhere. Yeah, I'm not convinced it's totally worth it to track that information just yet. Because I would need to think about the API implications of having that. Let's get back to our tree walker though. Okay, so stack entry. We have stack entry and we know we're gonna push onto this and pop from this thing. Whenever we pop from stack here, we need to make sure we destroy this node. Otherwise, its destructor will not normally be called. And weirdly enough, I need to allocate this thing using new, and I need to deallocate it and then invoke the destructor manually. Like, I just kind of hate this thing right now, but there's so many uses of this destructor currently because this thing was designed to be passed around on the stack and kind of just propagate everywhere. But what you need to do in the destructor is you need to decrement node references. So this piece of code is actually super necessary to have, and tracking down all the places where this is called is very non-trivial for now. So I might leave that for a different day. And it's actually kind of less related to arena allocation anyway. It's sort of like managing implicitly generated code. Slightly different problem. Another benefit to B-tree is it just counter. Yeah, that is kind of nice. And does it counter so it's been a little bit since I've looked at your implementation, but does that counter actually does it count the number of total nodes or just the depth of that particular branch? I'll let you formulate the answer there though. The last thing, of course, we need it would be just the depth. Yeah. So I think the fact that you track that information puts you in a much better position to just kind of propagate that to the tree walkers and make that whole process more efficient. Because if I could cheaply get that information, then I would definitely just populate these stack entries with a statically allocated array. Well, not statically, like it would just be an array that I can push and pop from. But because these red black trees don't retain that information, it makes it a little bit more difficult. Like because these are designed to not really be parented, or like they don't have pointers back to the parent, but because they're designed to be like arbitrarily reparented anytime, tracking the depth is a little bit I mean, it should be pretty simple because you should know that up front since these are purely functional nodes. It would just be like another field down here, like what your depth is. Yeah. Yeah, you could definitely do that, especially because these, like I said, these trees are purely functional, so like you can't just ad hoc modify them. And they're only changed by regenerating a new one from one of these things. So like whenever a balance action happens, or like whenever you remove the left, obviously you can start decrementing it, right? But some of these other ones, like the balance ones, are a little bit harder to track for my implementation, just because there's a lot of manipulations that end up happening here. Especially in Fuse. I think Fuse is like a pretty crazy function, right? Like here you end up having you would have to in the constructor of this thing, you would have to check like, oh, what's your left node, and then populate its depth up. I still think that wouldn't be too hard though. I still think that wouldn't be too difficult. Right. Yeah, and see, it kind of could be a step like this, where I'm already getting like the attribute of, so like the left subtree is the one that retains all of this information here. And so like as we're walking the tree, you only have to go down the left sides to get like the full meta information. Anyway, yeah, I think that's definitely a really good optimization opportunity, and something I will probably focus on in a different stream. Yeah, yeah, exactly. And that's kind of what it would turn into, Ratchet. Yeah, I think that would be pretty trivial to add. Yeah, and then I keep it probably like I could probably keep it in the node data as a new field. This way the red-black tree just still has one pointer worth of space. Anyway, back to arenas. So the arena, since this thing is always stack allocated, I can pretty much guarantee that this thing is not gonna like escape and become a big problem. So I'll just retain this since the thing here is like you only this data structure is gonna know when these things are gonna be added to and freed from. So I think having the arena be part of this is fine, especially considering these only ever exist on the stack. Okay, let's go into here. So we have, oh, actually, what are the orders of these things? The meta, it comes after the meta. It's total offset. Yeah, that's fine. So it's gonna need to be in all of these slots. Cool. And I kind of like having a little anonymous namespace to just collect up junk functions. I do this all over the place. It's nice because they don't like escape the translation unit, and you know that they're kind of like local computations to the thing that's like immediately enclosing them. So sort of like static, but it's also useful for types. So you can throw types in here and you know that nothing else can rely on them. Yes. Yeah. That's actually a good point. And actually, to do this, I'll just make these NSDMI. Non-static member data non-static data member initializers. These are useful for default values, but this is never going to be default, so I don't need that one. These are good defaults. Good call. So let's make a little stack push. I don't want to call this thing. And I think I want. Maybe I want to bundle these up in a tiny little struct. Um, so we got stack entry and stack. I'm just going to pull this out now and deal with the compilation errors as they come. Direction can also come out. How damaging is that going to be to the stuff down here? Why are we breaking? Why are we breaking down here? Left, center, right. Left, center, right. So we can deduplicate. We can actually just deduplicate all this stuff because I think these share. Let me just do this. These share the same implementation. Not sure why I'm seeing all this compilation error stuff though. That's a little weird. Tree, red black tree, direction. Cool. Does that start left? No, it starts right. Okay, that's really annoying. So like this non-static data member initializer is broken. Oh, yeah. Block stack, yep. Yeah, that's a good call. It's always weird how these little, like, yeah, that was a good call. That's actually exactly what it was. Yeah, because these member function or like non-defined functions in here, you would think that it only causes compilation errors down here, but actually, when you're looking at the header file, IntelliSense is sort of trying to take into consideration like the global context, so it like screws up everything. This is problematic because the stack entry for the tree walker wants to start with the left node. And obviously the reverse tree walker needs to start on the right side, the right subtree, which is why this exists. Left, center, right. They're the same directions, but this NSDMI is wrong. So I need to come up with a... I think I think that particular detail only comes up inside of these pushbacks whenever I don't specify a direction. So these are just going to have to become explicit lefts or explicit rights. Oh, that's so annoying. I think I remember why I had this as a NSDMI now. Okay, but this is gonna be an explicit API anyway, so we have to make this decision. But anyway, the reason I pulled this out as a stack list is because I want to be able to pass this. I want to be able to pass this thing, which contains both of these guys, into this API, so I don't have to do a friend and all that nonsense. I can just pass this like I'll just call it stack. And then you just say stack.stack or stack.freelist. Or even better, I'll probably just add an API here that's like top, and it would just give you the first one. Either way, we have some stuff to put in here. So first things first. And we're also going to have and then direction. And this actually gives me this not being default, I think, is actually a good thing. Okay, so for the push, we're first going to check do we have one on the free list? So if it's null putter, we actually got to allocate one. Or actually, let's do the not null putter first case. And then elsewise, we can have the like, let's assign it to the allocated version of this thing. Okay, so E is equal, so we want to pop, and then E is equal to, you know, I want to no zero this thing, and we actually need to allocate this as a blob first. And the reason is because it has a non-trivial destructor, and the way I have my arena set up is that it disallows non-trivially destructible things for now. Actually, this should just be unconditional. I don't want C++ things coming through here that I don't control. So we got a push array, no zero, and then aligned as well. We want to size of stack entry, and then ooh, that is explicit if you need to if you need to manually allocate up this stuff. So he and here's where things get a little bit strange, because I need to be able to now invoke new on this thing. So is equal to new. Yeah, this is where stuff gets super weird. I think this should just work. So I should be able to just be like, let's default allocate this thing. I probably want to zero it out first. Do I even care? I think maybe zeroing it out doesn't matter. It probably does not matter. Yeah, I don't think it matters. Yeah, exactly. Good old placement new. It's just I just hate this using this thing because I like the C++ standard is super weird about how placement new interacts with an object. And like technically, like the way the hardware works is that you shouldn't have to have this assignment like new. When you do this, it should just endow the location of E with this newly allocated object. But the way the object model works is like that technically doesn't, that's like ill-formed to rely on that. So you have to do this thing and it just looks weird and it's uncomfortable. But let's assign this to some stuff. Free dupe. And then actually we can just do tree like this. No, tree, let's do a dupe. Because these things are move only types, since they control like a ref counted thing. So we have to call dupe. And then direction. And now we're actually going to push it on our list. Oh, no, Q push. Okay. We don't really need a count because the only thing that matters is like, does this stack have an empty entry, right? And I think what I'll end up doing is E next. Just to be safe. Just to be extra safe. Because we don't want to be adding things to this list that just explode. Okay. So we want to take one off the free list and put it onto, or take one off the top of the stack if there is one. So if, or actually, let's assert that list stack is not null pointer. because I don't want to be calling this now for placement delete. Luckily, we don't need that. All I actually have to do is invoke the destructor. It's kind of like placement delete, right? It functionally is the exact same thing. But yeah, placement delete would be kind of funky, right? Like delete, X or something like that. Or like, wait, how would that even work? What would be the syntax for that? It'd probably be like, I don't know, if I were to invent a syntax, it'd be like this, put this into delete mode. I don't know, that'd be kind of funky. Right. So we're going to assert that we don't have null putter because I don't want to enter this function while we have nothing in there. So, and then I'll add like a free function that asks, does the stack have data? Actually, I'll do that now. So empty, right? And I can just take this by reference because I'm fine with const reference. Yeah, 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 exactly. Destructor. It is what it is. Return list. So it's empty if this next is equal to null pointer. Stack next is equal to null pointer. Or actually, no, stack. Right. Because this literally is the head of the list. And actually here, we're I'm just going to invoke the not. I'd be terrible at, interview questions because I would just like get this wrong and they'd be like, why would we hire you? Anyway, yeah, if the stack is empty, then that thing is empty. Okay, so we want to take the node off. So we get the head, and now pop. Done here. E next, no pointer. And now we want to invoke the destructor, right? Or actually, weirdly, I think I need to invoke it here. I mean, it doesn't really matter, honestly. Like, but reassigning it here and kind of like reusing the data, that's like fine. And let's put it on our free list. Okay. So we've asserted that we're not empty, and we also want to get the top. Oh. Let's get the top. Just as a little helper. Right. So we've invoked the destructor, which should decrement our ref count and keep everything internally consistent. We've invoked the constructor, which should keep everything internally consistent. Right. Okay, so first things first. What is that? Well, push our initial entry. So arena and what did I call it in the? I call it stack. And here we're gonna do root, or actually no, we can pass just root because we take it by const reference. And we want this one to be left default. So that should be taken care of. This is what we, whoops. This is what we want. So for seeking, we actually don't need to do anything. I mean, I guess we could. We can't really clear the arena because we're handed a scratch arena most of the time. Oh, actually, all the time we're handed a scratch arena. But yeah, we don't want to clear it. We actually don't care about this because this, anytime this is invoked, it's going to be like one time to start the initial fast forward to. I think this API might not even be used in the editor anymore, but it should be fine. So stack, we're gonna initialize it to empty again. Let's just, actually, I think, yeah, we can just drop the free list. We can just drop the free list. I think this is infrequent enough, and maybe I'll make it to do. Right. Ah, yeah, that is actually a good point. Ah, that's a very good catch. Just in case the stack. Yeah. Okay, yes. Okay, yeah, I think we actually do have to do that now. Yeah. That's a very good catch. Okay, so while did I really name it this? No, I did it wrong. Need to stack Walker. Can't believe I did that. Okay. Empty. So while this thing is not empty, we're gonna pop. Yeah. Yeah, I think that's probably, but like the need to clear this thing, I think it's only needed here. Yeah, I think it's only needed here. Even in, oh wait, I think we do call seek. Yeah, okay, maybe that's worth it. Maybe that's worth it to call stack clear. Right, I think you're right. I don't know why I'm getting all these errors, because it's fine. Yeah, you're absolutely right. Yeah, absolutely. Yep. And the destructor, yeah. But repeatedly calling stack pop should give us the effect we're looking for, right? And it will put everything onto the free list, which is what we want anyway. So, well, that's not empty. Right. I think that's what we want. And then it should be empty by the end of this thing. Cool. Yeah, that was a very good catch. Thank you for catching that. Otherwise, we want to do these two things. We want to dupe the root. So we do a clear and dupe the root, and we go left again. Yep. Cool. So for these, if we're empty, we're gonna say that we're exhausted. The invariant of these data structures is that if you have something in your stack, you have tree to walk. If there's nothing in your stack, you're at the end of the tree. You're done. Oh, this is annoying. Okay, why do we need to know the size? Why do we need to know the size? If there's more than one entry, we're still active? Oh. Hmm. I can keep a count. I can keep a count in this thing. Because if there's only one entry, right? If there's exactly one entry and this thing has failed to be populated, it implies that the tree has no data. That is exactly what this is for right here. Stack top next. Yeah, but do I need the sides anywhere else? I don't think I do. Yeah, maybe I could just get away with stack next. Hmm. Yeah, I think that's actually just a better. I think you have saved me twice this stream. At least. Yeah. So at this point, we know that the first element is there. Otherwise, this would have hit. So if we're empty, we're done. However, if stack next, this implies that count is greater than 1. Yeah, perfect. Okay, and then this is stack top. Um, I'm also kind of hating auto a little bit more. Like, the more I use it, the more I kind of just hate it. um, do I want this? No, I don't think I actually care that much about the syntax here. This is fine. Cool. Yeah, very good, very clever. Yeah, this is a much better solution than to keep a count. I mean, the count could be helpful for debugging, but I think this is actually just strictly better. Yeah, that was a good catch. Okay. Right. So if we're exhausted, we're done. Right. But if we pass exhausted, then we know there's one thing on the top. So um, top. No. Cool. Cool. So we pop that back. And then here we're getting the top again. But here we're getting the node in the direction. I think this is fine. Destructuring this thing's kind of annoying, but whatever. Okay, and then we get the back, or we get the top. And then we assign the direction to it because we want to go. We went down the left subtree. Now we want to go down the middle subtree, or like we want to pop back up to the middle and then eventually go down to the right. So like the right case is the very last thing we visit. So this is popping back up to the parent after we've visited the left subtree. So here we want to do this. So the direction for this particular stack entry is changed, and we want to pop, or we want to push a new stack entry. So I'm just going to copy this thing here. Except now we're replacing root with left. Cool. Do this. direction is that. Yeah, these stack walkers are kind of like a little bit complicated, a little bit more complicated than I want them to be, but they're very correct, and I do appreciate that about them. Stack walker back top. Okay, now we actually have our pop back. So this is, we visited the right subtree. We're ready to go back up to the parent of our parent. Wait, this one. Okay, yes, we visited the right subtree. We're done. And now we pop back up to the parent context. This is the case where we actually have no Stockwalker top. Yeah, okay. So this is where the node is like done, right? We haven't visited it. But now we're ready to go back up to the parent of our parent, which is why we have this. So we're ready to pop. Stack. So we get the pop. And now we want to push the next node up. This is kind of a hack, but I actually kind of like the way it works. So the way this functionally works is that we go back up to the parent and we have this parent on the stack, but in order to not revisit that parent, we actually pop it off and we pop or we push on the right subtree. So this way, when the right is all finished, that right subtree has been visited, when we pop back, we're not popping back to the original parent, we're popping back to the parent of that parent, which is why this pop happens first, and then the push happens. Cool. So now fast forward, which is equally as complex, but let's do it. So we get top. I'm kind of just going to copy this because a lot of the time we're really just changing direction here. So we're going to change the top. Let's actually do this for all of these. So changing direction. Okay, cool. Here's reverse subtree. Okay. That's going to have to change at some point. Yeah, reverse subtree is going to be super messed up. I don't know why we're not complaining about these pushbacks anymore. But, you know, I think I'm just going to roll with it. Node. So we're going to assert our stack's not empty. We assert it's not empty. Right, because as a condition of this, we're already in a left subtree, so we should have something there, even if it's like the sentinel node that we initially pushed. As long as we're in a left subtree. So pop. And now a push. And node. We're going to go left. Cool. Okay, so that should resolve this. I think it's really just these pushbacks that are a little messed up. Right. Next. Yeah, these pushbacks are the ones that are messed up. And that's because we are not using... We're not using designated initializers. So node... I did node here. That satisfies you. So I'm just going to kind of like work around reverse stack walker and do this everywhere. Because I want to address that separately. I want to be able to address the correctness of all the stuff we just changed around the normal stack walker. Okay. Is that enough to get it compiling? Nope. It's because there's no appropriate default constructor. Why? Why is this? Why do you? Oh, it's a. The constructor is explicit. Also, I don't need this namespacing. We're already in the piece tree namespace. Okay. That satisfied the C++ gods. Let's see if it actually compiles and links. So bring back our compile commands here. Don't forget to add a destructor that clears the stack. Oh. Oh, gosh, dang it. Dang. You keep me honest. Yeah, I definitely wouldn't have caught that until I noticed like a really annoying memory leak later. Nice catch. Very nice catch. Nice. Very, very good. Yep. Now we need more destructors, which I kind of hate, but this was kind of happening implicitly anyway, so we're just making it explicit. That's fine. Well, actually, it's not so fine because oh, this is actually a terrible interaction with the scratch arenas. So, like, let's just take any old example here. Tree Walker. We allocate the scratch arena, and then we deallocate the scratch arena here. However, when Tree Walker goes out of scope, it's after this scratch arena has already popped. So I actually have to make an explicit call to Tree Walker to something in Tree Walker to make it release those resources. So a destructor does not actually save us in this case. We have to add an API to address for that. So let me clear this for a second here. And yeah, and even adding a destructor on this thing won't work. It's too late. It happens too late. So we need to add like a API here to clean up the tree walker. I don't want to make it a member function. I kind of like the idea of having like making it kind of C-like where you just pass a pointer to this thing. So I think what I'll end up doing is like, but then I need to make this public and it's a problem with like all these little data structures that used to manage the memory by themselves. Like it just worked by magic of C++, but once you start managing the memory yourself, which does help you rationalize lifetimes a lot more, you lose some of the syntax benefit of having, you just create a thing on the stack and it just works. Okay. 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 So It's almost like what I want to do is have this stack allocated separately, or like keep it separate from the tree walker. This way the tree walker doesn't have an arena, right? It just kind of carries it with this stack list. And then I just like give the stack list to this thing. Or rely on the tree walker that has a ref the root and then not let it adjust the ref counts of the children. Yes. So essentially, like, instead of these being instead of this being like an actual C++ object, I could keep like a reference to it. However, all of the APIs on here generate a new tree. So I'd have to add APIs on here to like get the left or the right without incrementing the reference count. I think it's not the worst thing in the world though. It's like left, right, no like no ref count essentially. Ah. Yeah, no, that gets weird. It's almost like I just want to traverse. I kind of want to just traverse like the actual node itself, like this thing. Maybe I could just use this, actually. Yeah, I kind of like that idea. It makes it a lot less vulnerable to the weird situations. And because this thing, well, let me crap. There's too much crap open. Okay, I actually like that idea a lot because the thing that will end up keeping a reference to the tree is external, since this thing is passed as a pointer. So we know the tree has to be alive while we're doing this walk. And it's kind of enforced through these things as well. That way I can do like const ref RB node counted. Right. If we have this, we don't increment the ref count. We don't have to worry about destructors. We don't even really have to do... We don't even have to really do, like, this thing anymore, or, like, this thing anymore, the clear. I mean, clear's still helpful because it puts everything on the free list. But we don't need to do this. Like, that's just gone. We don't have to do this, right? We could just do... we could do push array no 0, and then this thing. E. I think it simplifies a lot of this code, actually. That's a really good call. Push array no 0, and we don't actually need to care about the alignment because the alignment's actually calculated for us. We only want to push one of these things. Yeah, see, look how simple the push array gets when you don't need all the alignment crap. Yeah, exactly. The clear can be a lot simpler. I think, yeah, since we don't actually need to care about this, I kind of love. I do like the idea of putting these things on the free list though. I'm still kind of a fan of this. Even though clear kind of will come up not very often at all. It's like one place. Yeah, I'll keep it as is. I mean, it doesn't really hurt. Um, let's do root putter. Root putter is this thing now. Our we want the tree to be actually RB node counted. I'll just call this node. We don't need this. We don't even need the placement new anymore, right? Like placement new is just gone. That is a beautiful thing. That is a beautiful thing. Very nice catch. And then we could do root footer. We can have tree walker keep a reference to the root. That's totally fine. Like sure, why the heck not? Root footer. Now the question is, am I able to calculate all the things I need to calculate down here? Because is empty. Let's see. The root node equals no pointer. I think this just becomes a comparison to null putter. Right. If the right. So if that thing's null putter up, if the right is null putter, then we're done. Some of these weird ones, like the left is empty. So if the left if it's not null pointer, we're exhausted if there's no right subtree, right? Okay. If this is that's equal to null pointer. Cool. So node root piece. Data dot piece. Data, yeah. Why isn't there? I don't think this needs to be const. This thing is already const, so that should be const by virtue. Yeah. This node itself is const. So this should have deduced to a const type, yep. Very good catch on that. Yeah, that's a much better solution. Having these things, just like don't count it, right? We don't need the counting actually. Wait, what am I doing here? Fast forward to root. So if it's not node is not null pointer. What is root doing? Just get our data. Okay. What? Why is this? Let me just confirm what the heck this thing is doing. Okay. So root, oh yeah, root always just gets the data. So yeah, that's fine. Root data. Root left. Node should be this thing. So we're just going to push the node. And this can be null pointer. That's fine if this thing is null pointer, because all the operations take into account null pointer. Right? Like that's what those is empty bits we're checking for. That should be fine. It's a lot of places where I was calling that thing. You just do this. Oh. There we go. Cool. Oh boy, do I really have to change this one too? It's like it's almost as bad as that last one. Christ. And the NSDMI is wrong too. The NSDMI is wrong for this thing. I think what I have to do, honestly, is just bring this back. I just bring this back, it should just work. Yeah. And I still don't need a destructor for this. Double check. Or like the automatic destructor generator for this is fine. This doesn't have a destructor. Stack is fine. Right, it has NSDMIs. I'll make this explicit. Equals that, just so it's like there. Try build. Okay, so the moment of truth. Let's see if this actually works. Ah, okay. We're already exploding. What's happening? I honestly should be using rad debugger, but I had a weird problem with rad debugger on these C++ types that are enclosed in anonymous namespaces. I definitely let Ryan know about it, so hopefully that will be fixed and I should be able to use them again. But why are we dying here? So the arena is invalid. Why are you invalid? Oh my gosh. Look at this. This is just the dumbest C++ thing I've ever seen. It lets you just assign to this thing even though there's no parameter. Holy crap. That's obnoxious. How is there no compiler warning for this? That's actually insane. That is just obnoxiously insane that it lets you do that. Wow. Yeah. Wonderful. Okay, that should mostly work. Okay, cool. And I should be able to copy stuff like this. Tree walkers invoke for this kind of stuff too, right? Right, that's all good. And we're not hitting any assertions. If I forgot to free, like, just to kind of confirm that if I forgot to free one of these things, so like, let's say, let's do a different one because that's going to be annoying. Let's do one that's like on the foreground thread. Retract by word, or actually extend by word is probably better one. Extend by word. Okay, perfect. Like, if I forgot to free this scratch arena, like, let's say I did this, we should hit an assertion after moving forward a word. Right. Okay, so we hit an assertion, but why was extend by word called? Why were you called? Fred, so it tells you the line where this thing was allocated. So it was an ed.cpp line 2382. So if I look at ed 2382, it's exactly here, right? So we forgot to pop the arena. I don't know why it was called. Oh, for the async search. Oh, okay, that totally makes sense. Let me show you what I mean after I kill Fred. Sorry, Fred. Stop the debugging session. So Fred has this thing where if you hover over a word, it like highlights the other words around it asynchronous. Like it highlights the other words around it. This actually happens on a background thread, but that's actually good because it tells me that the async, that the thing that was computing the scratch arena on the background thread was good enough to catch the problem, right? But yeah, any of these word movements and stuff, all this is all driven by the stack walker or the tree walker. I can copy, that all works by the tree walker, right? This is going to be lots of tree walker stuff. Okay. The functions I wanted to test were trim CRLF. So if I look at when those are invoked, we look for incomplete CRLF line endings. And this is to help drive a feature in Fred where if you turn off CRLF, you see all these line endings. Those are all the carriage returns. If I delete one of these things and I turn CRLF mode on again, you should get a warning here. It says, hey, you know, there's an incomplete CRLF here, but you're in CRLF mode. You know, here, use Control-7 to unify to CRLF characters. Boom, right? And that gets rid of it. That's kind of a nice feature. Especially when you're dealing with lots of files that have all kinds of different character encodings. Okay, cool. I think that pretty much worked. That's the one I wanted to test. UTF-8 extend, I actually already tested by doing word movements, right? So we tested that, which is really good. So I think all our testing, the weird functions, I think, are pretty validated at this point. Now we got to make sure that it's releasing the buffer correctly. And the way I've been testing that is like I open up I open up Fred and I kind of just check in Task Manager. Right. So right now I got to figure out the buffer usage. So something in OpenGL is like using a ridiculous amount of memory, and I think it's probably from me reserving a whole bunch of frame buffers because I use a couple of different frame buffers for well, one is so I can support things like having blurred backgrounds. And that one's like a pretty small frame buffer. It's like super tiny. So I don't expect that to be taking up a bunch of space. But there's a couple other frame buffers to support things like the CRT effect. This thing. This actually uses two different frame buffers because you have to kind of blit between them and perform various different operations. But I suspect something in OpenGL is, I don't know, eagerly allocating those frame buffers, even though I'm not telling it to allocate those. I don't know. There's something weird happening there. I'll have to investigate that separately. Point is, so to tell the frame or to tell what's happening, so I usually open up like ed.cpp because you can see a pretty significant bump in memory usage there. So I do like a whole bunch of operations here, like navigating around the text and all this stuff, right? So like this is going to generate like some extra nodes and things like that. Right. So we've done a whole bunch of operations and we've used Treewalker a whole bunch at this point, especially for like navigating. So I would expect to, when I close this thing, it won't deallocate the frame buffer right away because whenever you actually copy a section of text, like Control C, like this, it retains a reference to that frame buffer until you Control C, like, or until you copy a different piece of text, or something else externally copies to the clipboard for you. So if I close this, I wouldn't expect our memory to change that much. Right? It changed a little bit. It changed a little bit, but like when I do a paste here, that's actually using the original frame buffer that we just quote unquote deleted. But let me undo that. So now if I copy, I should expect the memory to go down, and we went down by about 1K, which is roughly what the size of that file is. It might go down a little bit more as the arena sort of catches up, but that's kind of what I expect to happen, right? So if I go open up ed again, right, we ran up, we should go down, right, roughly to 65,000 again. If I open up ed again, we go back up to 80, we should go back down roughly 66,000. So these little pieces of memory that are gone, those end up getting reclaimed by the operating system after you release the arena. So that little bump is kind of expected. But it should go roughly down to, kind of where you were, which is what I was at, like 65,000. That kind of makes sense. Let's see. Right, we went up to 80 again. I expect us to go down to roughly 65 again after, a couple of clears of the arenas. Yeah. So, I mean, we're kind of hovering right around ballpark where I expect it to be. Yeah, we're back down to 65,000. And it might go down, it might go up. It's kind of like, at this point, I'm sort of at the mercy of the GPU driver and what the heck it decides to allocate for. That's where those little pieces of memory are going, most likely. Anyway, yeah, okay. So we have arenas occupying the Treewalker. I think I'll probably call it there for tonight. We did. So I have this. This thing is good. Yeah, this is gonna need to change. We're gonna probably do reverse Treewalker next time I'm on stream. Yeah, I think that makes sense. Ratchet, thank you so much for your help you literally saved me from like so many dumb mistakes. I mean, obviously, I ended up going a completely different direction for this thing to avoid like the destructor problems and stuff like that. But it was per your suggestion, so that was super awesome. Yeah, this is just so much simpler. It's just so much simpler. Um, yeah, and honestly, I could even just get rid of this thing, but it doesn't matter since I'm allocating it. I'm allocating it on the arena anyway. Yeah, it's so much better. It's so much better than what it was. Let me make sure. Um, when I go to do this, okay, yeah, I was thinking for some reason I dropped this, but I did not. Luckily, yeah, that was super awesome. You are a lifesaver. Okay, let's commit this. Yeah, let's see how many changes. So we made 243 insertions and roughly 146 deletions, which is pretty okay. We did more insertions than deletions, which makes sense because we're adding manual memory management to this thing, and I think it's just better for it. You know, being aware of the lifetimes of your objects is super important for good software engineering practices and keeping yourself honest about how your program is behaving. So let's call this uh, for its internal state. Cool. That's it. All right. Thank you all so much for stopping by. I really appreciate you. Yeah. Follow Fred Dev. Go there if you're interested in checking out what Fred is all about. Join the Discord server. We're doing a lot of fun chat about programming and Fred and future things for the editor itself and the technology behind it. A lot of fun stuff. Anyway, thank you all for tuning in, and I'll see you next time.